Okay, I'm going to be working on this intervals intersection problem from grokking the coding interview. This is a merge intervals problem, and it is also here on LeetCode under the different title, Interval List Intersections. I have briefly read through this, but I haven't given a thorough look, so you are given two lists of closed intervals, first list and second list, where first list at index I is equal to start I, end I, and second list at index j is equal to start j, end j. Each list of intervals is pairwise, disjoint, and in sorted order. Return the intersection of these two interval lists. A closed interval AB with A is less than or equal to B denotes a set of real numbers x with A is less than or equal to x is less than or equal to B. The intersection of two closed intervals is a set of real numbers that are either empty or represented as a closed interval. For example, the intersection of 1, 3 and 2, 4 is 2, 3. Got it. Okay. So I have a few ideas. What I want my algorithm to be like is compare pairwise the start of A and B, and whatever is less. Oh, I also have it merged, so I'll write some of this down. So I have merged, and this is a set of intervals. Then we have A and we have B. And we want to look at whatever has a closest start time, or the smaller start time of A or B. And then if, so let's just say we have an interval from either A or B, we basically pop it off. If A is a smaller interval start time, we pop A off. If B is a smaller interval start time, we pop B off. So let's just say for the example that A, that start of A is less than start B. Then we could say we want to compare that to the last value of the merge index, which will be so let's just say the merge interval is 1 to 5, for example, and A is like 3 to 8. So we merge these two, but we also keep track of the intersection and we append it. So the intersection would be that occurs when the end of this is greater than the start of this, and the intersection would therefore be the start. Let's call this 2, and let's call this 1. So intersection would be start of 2, end of 1. So that's our intersection, and then also we append to the merged a new merge interval, which would be 1 to 8. And then we append this to the merged interval over here, and then we repeat this process where we pop from either A or B, and then we do this process one more time. Or we continue until we have no more elements. Okay. So I'll just do a list. Oh yeah, because we can't necessarily pop from the left side of the list, I'm just going to reverse the list. So this is the same list except all the elements are in backwards order. So it's largest to smallest in terms of start times, and we will be iterating from right to left instead of left to right. It shouldn't make a difference, but this way we could pop from the list pretty easily. So I'll just do this, merged is equal to, and then we also want intersections equal to. Okay. So append a list pop merge dot append blist.pop. So I want a value in merge, so we could start off the merging process. I'm just going to choose one at random. If a list, then I'm doing it like this just to ensure that we don't pop from an empty list. And if both these happen to be empty, we're returning just empty list. Okay. And then we do our merging here, and then we return our intersections. Okay. So while a list and b list. So these both have to have valid elements because we're going to be doing a comparison between them, and we can't do comparisons between values that don't exist. Afterwards, though, however, want to check if one is null. There is not. So we want to check after the end of this merging process, like say we depleted all the values in A, we want to check if B still has values in it, because I think, for example, like say we have A is 1 to 3, 4 to 5, and then 6 to like 100, and then B is like 60 to 70, 70 to 80, 80 to 90. We're going to go through the entirety of A before we get to B, and we can see that B all merges with this one value right here. So A will be null, and then we still need to merge all of these with V, and we have intersections that are I think there's a better way to solve this though too, because yeah, I feel like there's some intuition here that could reduce the complexity of this problem. but it's not coming to me immediately, so I'll continue solving as is and I'll take a look afterwards if I need to. So start is equal to if start is equal to start. Okay. Start equal to okay, so this is to do a comparison whether or not we will use the A list or the B list, depending on what starts sooner, is that's the one we'll use to merge, whatever. Okay. So A start less than B start. This means we use A. End is equal to A list -1 start end is equal to B list -1. From here it's just standard merging and keeping track of the intersections. So here we also want to pop from A list pop. And here we want to pop from B list. Okay, because we want to remove the value that's the smallest after we use it, so we don't use it more than once. Okay. M start should be the one that's on the left. These should be the one that's on the right. These should have starting times that come after M start. So if M end is greater than or equal is greater than. Ooh, yeah, hold on. I want to see how. Okay, so yeah, I was curious to see how, if they were equal, what, like the start of one and the end of one were equal, what the result would be. But it looks like it's just that value in both the start and the end of the intersection. Okay. If M end is greater than or equal to start, so inter is equal to what was it? It was start and intersections dot append inter merged interval is equal to and that's start. This is wrong. There. Let's start, then max of m.end and the normal end. Merged dot pop, merged dot append, merged interval. Otherwise, return merge dot append. Start end. Yeah. Okay, this looks right. Okay, this is almost done. Now we just need to check if A list, else if B list, else. I'm trying to think that I should have created a method for this. Yeah, this feels like it could be a method. And is equal to B start, B end is equal to A list dot pop. If start end is greater than equal to B start is equal to I'm just reusing a bunch of the code because it doesn't change too much between these two. It does change a little bit, but not a whole lot. Okay, I'm hoping that this works first try. Line 10, invalid syntax. Else if B list. Nice. Ooh, not nice. Okay. First list is 510, second list is 310. So we skip past this first code, skip past here, and we're in here. This is equal to 5, this is equal to 10, this is equal to 3, this is equal to 10. Okay, I need to take a close look at the intersections. So it works right here. Let's have this be 3 to 10, this be 5 to 10. This is A, this is B. Our intersection will be B start and A end is greater than or equal to B start. If A of end is greater than or equal to B start. Output. Okay, so I think it still works. I just need to do a comparison right here. Okay. Yeah, so I'm not picking an arbitrary one anymore. I'm picking whatever of these two values is smaller. I think that would fix our error from last time. Otherwise, else if B list, else if A list, else. Passing more, but this is still incorrect. Okay, let me trace through this. This is what I outputted, and this is what was expected. Yeah, no, I'm pretty sure. And I think this might be what the problem is. And the end. Yeah, okay, so that works. Took me to get there. This runtime solution is slow, but not much slower than the standard, about 20 milliseconds. The space, also not amazing, but again, oh, actually, yeah, quite a bit worse. Okay, that's fine. But yeah, that's my rundown of this problem. The time complexity, these each take of n operations. Yeah, so our time complexity in this case would be length of first list plus the length of the second list. So we're iterating through both of them. Space complexity, you have this merged list. This would be also both of these, so O of n plus O of m. Alright, thank you for watching.